Up to this point in the Data Structures and Algorithms lecture series, we have defined abstract data types, data structures, and algorithms. And throughout the videos, we've mentioned a little bit about how they relate to each other and how they interact with each other. But I wanted to take a moment to kind of recap all that and make sure we're all on the same page. Recapping all the definitions, we know that an abstract data type specifies the properties and functionality that's but independent of a particular implementation. So we could have multiple implementations of a single ADT. And that a data structure is a collection of data whose structure and functionality is defined by an ADT. And algorithms are step-by-step instructions that will use data structures to solve various problems. So each of these concepts are distinct, but they also are highly dependent on each other. So you could have an algorithm that doesn't really use any data structures except for maybe some of the primitive ones, int, float, boolean. But you can also have an algorithm that will operate on an ADT, right? Will interact with, okay, how should I interact with this telephone book? Or how should I interact with this car? But then you can have a data structure or an ADT that is defined with functionality built in. Now, all that functionality that you have to define, you should develop an algorithm for. So if you are developing a list ADT that has the ability to be sorted, has the ability to search and find if elements exist in the list, or has the ability to remove every element from the list, how are you going to perform those steps? Well, that's where algorithms would come in. So all three of these, although they're distinct concepts, relate with each other and utilize each other to give us the full power of what we can do in computer science. Throughout the remainder of this Data Structures and Algorithms series, we're going to be taking these core concepts and we're going to be manipulating them, using them, really becoming familiar with them and how they interact with each other, and how with maybe a decision we make when developing an ADT is going to drastically affect the types of algorithms that we create with it or create for it, and vice versa. So there's a lot more to cover, but the key thing here that I want you to come away with is ADTs. They will allow us to design things at a logical level. Data structures are the implementation of these ADTs that allow us to actually manipulate data, actually store data. And algorithms, kind of the glue. It's what really gets everything moving, everything working. So without these three concepts, we'd be kind of dead in the water before we even got started.